All right, folks, I wanted to continue on with section 1.2 in calculus about limits. Okay, so in the last class, we said that a limit describes the y value or the function value that is approached as x approaches a given value, call it c. Well, the first thing I want to talk about are one-sided limits. In limits, because we're approaching an x value, I could actually approach that x value from the left side of the value or from the right side. Now, what you'll see here is in this notation right here, if I have the limit as x approaches c, and then you see a little minus sign here, this means that you are approaching the value of c from the left side of c, or using numbers to the left of c. Whereas if you see the limit as x approaches c, and then you see a little positive sign, that means I must be approaching the value of c from the right side of c. Okay? So the most applicable part to this is when we look at piecewise functions. For example, suppose I have a piecewise function that looks something like this. If I have a graph that looks like this, and we'll put a closed circle and then an open circle like this. Let's suppose this y value is 7 and this y value is 2. Say this x value is 1. Well, I would say that the limit as x approaches 1 from the left side of f of x, assuming that this function is the f of x function, well, if I were to trace this on the left side of 1, I would come in and follow this path. Well, what y value is this guy approaching? Well, it looks to me as though it's approaching the y value of 2. So we would say that the limit as x approaches 1 from the left of my function is 2. Now, if I wanted to come in from the right side of 1, I would say as x approaches 1 from the right for f of x. Well, now I have to come in from this right side. Well, in this case, it looks like the y value that I'm approaching is 7. So I have a limit from the left side of 1 and from the right side of 1. Notice that these two answers are totally different answers. Many times, your limit from the left and the limit from the right, they will agree. They'll have the same answer. And we looked at that in the last class. But the importance of these one-sided limits, and one-sided limits almost always are going to yield some type of number or for an answer, okay? But these one-sided limits lead to an important idea of the overall existence of a limit. And here's what it says. For the limit to exist, if the left-sided limit is equal to the right-sided limit, then we say that the overall limit, notice that there is no plus or minus. If you see x approaching some number, call it c, without a sign there, this means that you have to give me the answer from both sides, the left side and the right side. And the only way that you're going to get an answer for that y value is if you get the same answer both times. Again, in this part right here, it says the left-sided answer has to equal the right-sided answer. If they do equal, then we say that the overall limit is whatever that answer is. Now, let's take a look at some examples. So in this problem right here, I've got a bunch of piecewise functions. Let me come back down here again, sorry. So in this problem, and I often like to draw little stick figures here, right? I'm going to put this guy over here. Now, in the first problem, it says, I want to find the limit as x approaches 1 from the left. Well, if I'm approaching 1 from the left, I'm going to drag my little person here, following the left path. As I approach 1, doesn't it look like the y value that we're landing at as I approach 1 from the left? Doesn't it look like I'm coming in for f of x Wouldn't that equal -1? But in the next problem, I want to find the limit as x approaches 1 from the right. Well, in this case, my little guy is going to come in from the right, and I'm going to follow this path, and then boop, jump up, and then slide down. Well, if I came in from the right side, well, it looks to me as though, in this case, this limit for f of x would equal +1, because I'm coming into this y value of +1. Well, here's what this rule for the overall limit says. If I want to find the general limit as x approaches 1 from both the positive and the negative side, well, the only way I'm going to get an answer is if the left-sided answer and the right-sided answer are the same answer. Well, since the left side is -1 and the right side is +1, then we say the overall limit does not exist. And if you've ever seen the movie Mean Girls, you'll know what I'm talking about. This limit overall does not exist. Now, if you take a look at this, most of the time when a limit doesn't exist in these cases, that'll happen when you have a jump in y values. We call this a jump discontinuity, right? So just looking at this graph, I can tell when a limit isn't going to exist because of jump discontinuities by just looking at where is there a difference in the y values. Well, again, I see a jump right here at x equals 1. I also see a jump right here at x equals 4. So I know that the limit here should not exist because the left-sided y value here in this F4 does not equal the right-sided y value. Now, so let's take a look at this problem. If I want to find the limit as x approaches 4 from both sides, I have to break this up into the limit as x approaches 4 from the left of f of x. Well, it looks like if I'm coming in from the left, that looks like I'm coming into the value of, looks like 3. So I know that this limit is 3. Now the limit as x approaches 4 from the right of f of x, well, again, following the right path, the right side of 4, going backwards, this value I'm coming into is 0. Well, since these two values aren't equal, then I would say that the overall limit as x approaches 4 overall of f of x does not exist. Let's do another one. If I've got the limit as x approaches 5, well, in this case, let me erase this real quick here. If I'm coming into 5, okay, well, from the left side of 5,